Happy spring break, y'all. So just one video that you have to watch here on indeterminate forms and L'Hopital's rule. So what we did limits the very first thing, and I basically forgot to go back to L'Hopital's rule once we learned derivatives, because some limits you can't evaluate because they're in what's known as an indeterminate form. So the first indeterminate forms that we're going to talk about are, they look like this. So indeterminate, which means you can't determine them, basically. Indeterminate is 0 over 0. So you can't divide 0 by 0, and infinity over infinity. Okay, so as a limit example of this would be the limit as x approaches -1 of 2x squared minus 2 over x plus 1. And previously, how you would solve that is, so you would get 0 over 0. Remember not to put an equal sign. So do not put this, like don't put an equal sign, put an arrow, because something can't equal 0 over 0. The algebraic technique to solve that would be to divide the numerator and denominator by x plus 1, so factoring the top, basically. And then the other one for as x approaches infinity of 3x squared minus 1 over 2x squared plus 1. So both of those are growing exponentially large, so you get the indeterminate form of infinity over infinity. All right, so a shortcut to this, instead of using algebra, because sometimes the algebra can get a little tricky, is saying L'Hopital's rule here. We have, we'll make this purple. Okay, so L'Hopital. It's French, that's the guy's name, L'Hopital. Is let f and g be functions that are differentiable on an open interval a to b containing c except possibly c itself. So it can be differentiable, which means it's continuous on the interval from a to b, which includes some point c, except there might be some point where c does not exist. And in order to do this, if we assume that g prime of x does not equal 0 for all the values from all x on the interval a to b, and I need an in here, in a to b, and again, except possibly c itself. I will just clone this. So if the limit as x approaches c of f of x over g of x produces an indeterminate form, of 0 over 0 or infinity over infinity, then this is the part that you need to know. So, I mean, you need to know all of it, but the most important part here is that you can say this. The limit, that not work. The limit as x approaches c for f of x over g of x is equal to the limit as x approaches c of f prime of x over g prime of x. Okay, there are more than those two indeterminate forms, but those are the only two assessed on the AP exam. So we're gonna focus on those two. All right, so let's look at an example. So basically, if you find that you get an indeterminate form, you take the derivative of the numerator and then the derivative of the denominator, and then hopefully you can get an answer that's not an indeterminate form. So we're going to evaluate the limit as x approaches 0 for e to the 2x minus 1 over x. Now, on the AP exam, if it asks you to do this, especially on an FRQ, what you're going to want to do is you're going to want to write the limit as x approaches 0 for e to the 2x minus 1 over x. Then you're going to put an arrow, and you're going to say 0 over 0. You have to verify that condition, that it's an indeterminate form. As all of you AP Stats kids cringe, yes, you have to check that condition. So now that I know that I get an indeterminate form of 0 over 0, because e to the 0 is 1, so 1 minus 1 is 0, and then you just plug 0 in for x, I can now say that this is the limit as x approaches 0 if I take the derivative. So the derivative of e to the 2x is 2e to the 2x. The derivative of negative 1 is 0. And then I'm going to divide it by the derivative of x, which is 1. Okay, now I can plug in 0, and I get equals 2e to the 2 times 0, which gives me 2. That's it. So verify that it's an indeterminate form, take the derivative of the numerator, the derivative of the denominator, and then try to plug in your c value next time. And hopefully you get an answer. Okay. Next example. Let's do infinity over infinity. The limit, evaluate the limit as x approaches infinity for ln x over x. Okay, so the first thing we're going to do is verify that it's an indeterminate form. So the limit as x approaches infinity for ln x over x. Well, the end behavior for ln x as you approach infinity is also infinity. And yes, it's assumed that you know that without a calculator, because in your head you have the parent graph of ln, which looks like this. That's actually really gross. Let's try that again. Okay, looks more like this. So it doesn't have any negative values for x, and then as you approach 0 from the right, your y values approach negative infinity. So that's a recall graph ln x. Okay, and if I plug infinity in for x, I also get infinity. Okay, so that means that I can take the derivative of the top and the derivative of the bottom. So I get the limit as x approaches infinity. The derivative of ln x is 1 over x. The derivative of x is just 1. Equals, okay, if I have my denominator getting really, really big, then that means that I'm getting closer and closer to 0. So this answer is then 0. 0 divided by 1. Okay. All right, what about, what happens if you do L'Hopital's rule and then it gets you nowhere? And you're still at an indeterminate form. What happens then? Well, let's see. With example 3, we're going to evaluate the limit. Also, if you have any questions during this entire process, make sure you star the part, write down your question, send me an email, or write it down so that you know to ask about it after break. And we will talk about it. So, okay, so let's see here. If I'm approaching infinity, so this then gives me the indeterminate form of infinity over infinity. So another way that you can do this is just from the, from this, instead of writing it out again, putting a little arrow. I want a different, okay. Technology. And I get infinity over infinity. So that means I can apply L'Hopital's rule. So I'm going to take the derivative and I get the limit as x approaches infinity. The derivative of x squared is 2x. The derivative of e to the negative x is negative e to the negative x. Okay, well, unfortunately, that still gives me infinity over infinity. So what are we going to do now? We're going to perform L'Hopital's rule again. Okay, so let's take the derivative of the numerator. Give me 2. The derivative of the denominator to give me e to the negative x. Now when I plug in infinity, I get 2 over infinity, which means that this is approaching 0 as my denominator gets really, really big. Okay, the next part of this chapter in your book talks about other indeterminate forms like 0 times infinity and there's some other ones, infinity, 1 to the infinity, 0 to the 0. Those are not tested on the AP exam, so that's really all it is. If you want some practice problems to do for that, want might be a strong word. Here are some homework problems. Homework/practice. Okay, so that was only 3 examples. Let's see here. Let's do 5 through 11 odd. And 21, 23. Let's see, what are the AP practices for this section? and 13 through, or sorry, 115 through 115. And this is on page 513. Okay, so also don't forget that there's a practice calc exam. I would like to know where you're at, so try that practice exam on your own. There's instructions on campus. On your own, without your notes, how does it go? And then that's all. 15, 16 minutes, not too bad. So I hope you have a great break, and if you need anything, feel free to reach out.